17, almost there. Try and get 1 or 2 more people in. I know a couple of folks have told me why they're not able to be in, and that's okay. All right. It's good to know. All right, good. So let's go ahead and get started. The goal of this activity is going to be to introduce you to holes and vertical asymptotes for rational functions. And what these are is they're like forbidden zones. They're areas or a point where a function ceases to exist. Right? All of a sudden it's like poof, doesn't exist, and then poof, it comes back again on the other side. It's pretty wonky, but it almost always has to do with having a function be something called undefined, right? And we've talked about this in the past in terms of the domain. When we were finding the domain of a function, we were looking for 2 things. First one was if there were any negatives for square roots, because we can't have a negative, take the square root of a negative. And the second thing was we couldn't divide by 0. Okay. So, and so what I want to make sure we do is take a look at the equation every time we look at the graph. And I'm really going to be asking you and pushing you to think about what you're seeing and how you can find patterns and commonalities. So let's start on this screen, and I'm guessing you already clicked on it and got the definition of holes. And then now take a look at the equation. All right, and Andrew, what's the first thing you notice when you look at the equation? Yeah, go ahead, Sherry. What do you see?
It's a fraction.
Yeah, we see a fraction. Good, Angel. And then Madison, what did you say? Looks like
That x minus 2 cancels out.
Yeah. Okay. So here are 2 huge important things to notice. First one is that we are dealing with a fraction, or in the college algebra and pre-calculus, and we call this a ratio or a rational expression, right? Because it's expressed as a ratio, something over something. And then the second thing that just kind of jumps out at you is that you have something that could cancel. You got this x minus 2 that's identical on the top and the bottom, right? Those are called identical sub-expressions, okay? And so these guys would normally, when you were doing your simplification, cancel out. And if we did that, then all we would have left is f of x equals x plus 2. Well, look at our graph. What's the y-intercept here? All right, Krista, what's the y-intercept? It's okay to put it in the chat if you want to. Other people feel free to jump in, that's fine. Delaney, what is our y-intercept here? All right, I've got some great responses into the chat. Thank you. 2, yeah, Queen Leah and Katie, that's exactly right. Our y-intercept is 2, and it comes from right here because it was f of x equals x plus 2. That's that vertical upwards transformation of the y equals x graph, right? This has a slope of 1 over 1 up 1 over 1 up 1. Okay, so now why is there a hole here though? What happens at this point? Don't answer yet, because I'm actually ask you to type it into the next screen so I can kind of see everybody's thoughts at once and then pull out some of the ideas that I see starting to appear. Okay, so I'm going to swoop you all to the second screen here. And if you would please type into the response box, and I'll be watching to kind of highlight the good points and gently correct some misconceptions if they show up. Remember, see what your actual name is on the screen so that you know if I'm talking to you. Why is the hole where it is? What caused it? And how is it related to that equation? And it's okay to not be sure right now. It is. It's totally fine to not be sure. But it's also okay to guess, right? Because right now we're just dipping our toe in. And it could be that we find some pretty interesting things come out just from those guesses. Good. So there's the mathematician Mario Vasquez, right? The x minus 2 being on both top and bottom. Absolutely, that's important. That has something to do with it. Okay. And then, ooh, I see someone starting to think about what can and can't happen in the denominator. What is that forbidden thing in the denominator? Good. And I like that one. Okay. So I pulled a few of those responses, and it's all right if you're not quite done yet. Go ahead and finish your thought. But I'm going to have you periodically switch back over to your Zoom window so that you can see the things that I'm presenting, because what I'm doing is I'm pulling from folks' responses, and that way I can kind of highlight some of the good things that we're seeing happening. Okay, so go ahead and oh, I have a shortcut to teach you. All right, so everyone take your left thumb, okay, left thumb, and push down the Alt key and keep it there. The Alt key is to the left of the space bar, okay? And then with your like third or fourth finger, hit the Tab key once with the Alt key still pressed down. You see what's happening? And then if you let go, it'll move you to that window. Isn't that cool?
Cool.
Yeah, right? Because we should do a lot of swapping back and forth. So this is a great way to do it, because you can just go Alt Tab, it'll swap you over to where you want to be, and Alt Tab, it'll swap you back to where you were. All right, so if you are looking at the Zoom window, you should be seeing my screen that has the 3 responses on it. Can somebody just give me verify that that's what you're seeing?
I can see it.
Perfect, thank you. All right, so this first response I really like, because even though this person said that they weren't sure, right, they hypothesized that it had something to do with the fact that if x minus 2 equals 0, then x can't equal 2. And if it can't equal 2, then that would make sense that there would be a hole associated with x equals 2. Right? Okay, good. And then this one I like also, because here we're starting to think about the denominator, and the denominator being 0, right? If the denominator can't be 0, because it's impossible to divide by 0. You cannot do it. It just cannot be done. And so when you get to a point where you have a value that you want to put into your function that creates a denominator that equals 0, all of a sudden it's going to go poof and disappear, because it doesn't exist at that point. Right, so that's great. That's where that hole would be, is where that denominator is made to be 0. And then here's the last piece of the puzzle here, guys. This is the last piece of the puzzle. You put all 3 of these together, and you have everything you need to know about finding holes. Right? It's because x minus 2 is both on top and bottom. Because if we made x equal 2, so at this point where it goes poof, disappears, at x equals 2, at that point, the numerator and the denominator would both equal 0. You would have 0 divided by 0. Okay? So that's the requirement for a hole. You have to have a canceling out on top and bottom, of something that if there was a value plugged in for that X, that it would cause both of those things to equal 0, so that you ended up with a 0 in the numerator and a 0 in the denominator. All right, good. Now, think about those people's responses. Go back to your Desmos, please. So you can just hit Alt-Tab. Alt-Tab will take you back. And this time, I want you to predict. So you're going to actually grab the marking tool and draw on the graph itself on your screen. And I'm going to be able to see what you draw. Very cool, right? I want you to draw onto your screen where you think that hole is going to be, and then back it up. Don't just put it there, back it up. Why do you think it's there? And remember what we just talked about. Try to connect all those pieces into the same puzzle. I'm just going to wrap up attendance here. Damien, did we ever show up? Nope. Okay. Wow. Great attendance today. That's fantastic. So glad you guys are all here. I hope you're going to come to Brick Day tomorrow and that they're going to have free food. I mean, come on, free food. Doesn't get much better than that. All right, good. So I'm seeing an awful lot of dots showing up in the right place. Remember, look at your name, your mathematician name, and that way you'll know if I'm talking to you. Catherine, that is the perfect spot for your dot. Margaret, perfect spot for your dot. Marielle, perfect spot. Sun Young, perfect spot. Let's see. Now, the rest of you either haven't put a dot in or the dot's in kind of a weird place. So I want you to think about, how did we get the value of 2 on the last problem? What did we look at? We looked at the equation, right? We looked at the equation. We had to figure out what value of X resulted in a 0 on the top and a 0 on the bottom. If you look at the equation for G of X, right? So MC, if you think about that equation, what value of X would result in a 0 for the answer? Okay. So there, when you find that value, now back it up. Remember, we said there were basically 3 things you had to think about. You had to have a value that resulted in a situation where you had 0 divided by 0. And that had to come from having identical sub-expressions on top and bottom that canceled out. Okay. Good. And that they canceled out. Well, I guess I kind of got all 3 of those things in there today. Good, yeah. +2, -2 from before. This one's got to be, there we go. And I've seen more dots show up in the right place. All right, Margaret, Bao, Juan's, this is horrible. I mean, I can't even pretend to not butcher these names. The Chinese name, which is HX, correct, perfect spot. All right, good. And now for your explanations, I'm seeing a lot of people say things like, it can't be 5. Right, I see that at least 4 times from folks here. It can't be 5. Well, okay, why not? And why does that cause a hole? Right? Think about how you can put all of it together. Angel, we'll see you later, hon. tomorrow? Okay, so let's see, I'm getting a little bit more detail from folks. I'm seeing things like the word denominator and numerator, right? Good, those are words I want to see. Those are important words. The denominator and the numerator cannot be what? If you're going to get what number is going to make that happen. Good. All right. Most people have the hole in the correct place now. You should have your hole right at, and I'm going to go ahead and swoop us forward so you can see the answer to this one. All right. So we're now looking at slide 4. And you'll notice that I've shown the hole at 5,7. All right, make sure that you're starting to think not only about the X component, but also the Y component. Where that hole is located requires coordinates, right? An X and a Y coordinate. So you'll notice the 5 is because that's the verboten value. That's the value that's forbidden. So if you had 5 minus 5 on top, you get a 0. 0 times anything is 0. So the whole thing collapses to 0 on top. And on the bottom, it would be 5 minus 5 collapses to 0 on the bottom. So if these aren't canceled out first, then the value of 5 would collapse the top and the bottom to both 0, making it a hole. Then the 7, there's 2 ways you could have figured out where that 7 is, okay? The first way is by just looking at the graph itself. Like, you've got to be at X equals 5, so follow it up to the line and then follow it over. And by golly, it's at 7, right? The other way is to take your X value, which is 5, and cancel out the stuff that made the hole, right? So cancel out those guys. And then you've got 5 plus 2 for 7. Okay, 5 plus 2 to give you 7. All right. Yeah, it is what it is. Eliza, we've got a lot of emergencies happening here today, but those of you that are still with me, thank you. We will keep going. All right. Any questions before we go on?
Hey, Miss.
Yes.
I have to go. I'm really busy at work and I can't stay.
Yeah, I understand. Yeah, in an ideal world.
Longer.
All right. Good luck. All right. I appreciate the effort that people make to try and do more than one thing. But I also appreciate those of you that make sure that you're able to focus during class. I do both sides are important. All right, so moving on. This one gets a little bit harder. And there's a hint there if you want it. Okay. You don't necessarily need it though. I think you can figure this one out. Because I've given you a pretty big clue just in the function itself. By putting that X minus 1 on the bottom, it's a pretty big clue about what's supposed to happen here. It might be sometimes that the answer is there are no holes, but there is a hole on this one, I'll tell you that. And so if there's an X minus 1 on the bottom, what must there be on the top? Okay, as you are trying this, I'd like to see you actually show your work on the screen. And you can do that with the math tool if you don't want to try and write with the mouse, because we know how horribly atrocious that is to do. But I want to see your rationale, because I don't ask you to explain this one, because I want you to explain it using math on your actual graph. You can use the math type, or you can try handwriting it. But give me more than just the dot. Oh yeah, that one's looking really good. I can see exactly where you're going with it. KYNE, I'm guessing is kind. That
Yep,
looks
that's
like,
me, Dr. Bass. Yeah,
okay, looks like you're on the right track, Katie.
yeah, thanks.
Let's see, good. Catherine, looks like you're on the right track. Very good. Yep. Oh yeah, that one's perfect. That is exactly how you would show your work. And then if you ever had to back it up with words, you could think about what that would be. But AHMES, AHMES, your dot is definitely in the right place. Now, can you back it up with some justification mathematically why that's the right place? We know that we would have to have something on the top and something on the bottom that are identical, that would cancel each other out, and at the value of the whole would create an undefined and a 0 over 0 equation. We have to do the top. Good, 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 good. If x cannot equal 1, very good. Okay. There's just another minute or so. Still love to see a little bit more justification insight on a couple of these. David Blackwell, your dot is in the correct place. I'd love to have you show me why that's correct.
Miss, for some reason it says I'm David Blackwell.
Yes, and so I anonymized everybody.
Oh.
So all of these names are of famous mathematicians. And I did that because right now I'm just recording the screen for my evaluation. And so since I have you guys going back and forth, I didn't want you to feel like, awkward.
Pressured.
Yeah.
Okay. Cool.
So
Thank you.
enjoy your life as David here for the next 20 minutes. Good. So both the numerator and the denominator have to contain the identical sub-expression. And when a certain value is placed into those, whenever a certain value of x, it ends up resulting in the numerator and the denominator collapsing to 0 and a 0. That's what creates a whole. And finally, give me the coordinates, not just the x value, but give me the y value and show me where that came from. Did it come from just the line, reading the line, or can you also show me mathematically where it came from? Ingrid, I like the factoring by grouping. You're getting there. Sun Young, that one looks good. I can read anything. It's another one of my teacher's superpowers. Yep. that a 2 or 3? 3. Good. So it's a 3. And yep, I see the mathematics for it. Very good. Very, very good. So remember, even if you think you're done, go back and also make sure you identify the full coordinates. Right? The whole is at x comma y. What are the values for x and y? Good. And the only other thing is when you are justifying this stuff with the math, make sure you're showing me the fully factored form. I'm gonna go ahead and grab a screenshot here of a couple of folks just to show a couple of different ways to approach this. And we'll take a look at them together. Oh yeah, I want to grab yours. I just want you to finish that last step before I hit the snapshot because it's excellent. With the mathematician named Margaret, would you please try to show me the factored numerator? How would you factor that into 2 parentheses? As close as we can get. All right. Go on back over to the Zoom window for me, please. And take a look at, whoa, that was not good. Reset. Take a look at these. Look at them one at a time. So maybe this will be a little bigger. Let's see. All right, good. So this one's excellent because it's showing the steps for the factoring using the factoring by grouping method. And we just needed to finish it up at the end because at the end we would have had x plus 2 removed and like factored out as a common factor. And then there's a 1 right here. So it would have been x minus 1. Okay, so that's the last step that we just wanted to see. And you can see that if I show you then on this one. Right? So here what we've got is the final factored version. X plus 2, x minus 1 over x minus 1. Right? So that all that we did there is take a times c, found the 2 values that would add to 1 and multiply to -2. And that's what these guys are. And now we see where the whole is. It's going to be at x minus 1. All right. So if it's x minus 1 is our key point to look at, set it equal to 0, you end up getting x equals 1. And it's 1 comma 3. First off, because I can read it off the graph. But second, because if I cancel these x minus 1s out and I insert my value of 1, remember that's the one we got, 1. 1 plus 2 then is 3. All right. So good job, you guys. I'm going to go on to, here's the, oops. There, that's where I want you. Here is the response that I put together. You can see it's the same in that I've got it factored out. And then there's the whole at 1 comma 3. All right. So holes. They're new. We haven't done anything with them before, but the concept isn't new. This idea that there's a restricted area, right? A restricted zone where something can't exist. We've been dealing with that with domain since module 1 or 2, I think, all right, of the last quarter. So as we continue on with this, into the world of asymptotes, I want you to see how we're continuing this idea of finding places where the function cannot exist. And this one's actually even a little bit more straightforward than the holes. And we've been doing them, right? So asymptotes come in 3 flavors. They come in horizontal, vertical, and then my personal favorite, oblique, just because I like saying oblique. It's kind of like Queen Leah. That's awesome. Queen Leah. So the obliques are the ones that are the diagonals. And we are going to only tackle this week the verticals. So don't worry about horizontals or obliques until next week. Right? So let's take a look at vertical asymptotes. And this is going to be kind of the same game. I want you this time, though, to grab the line tool, the line segment tool. Okay, grab the line segment tool and looking at the graph there on slide 8. Wow. Looking at the graph there on slide 8, put in a vertical asymptote for me and then tell me where it is.
Dr. Maz, I cannot get to slide 8.
That's weird.
I'm not on slide 8. I'm still on like slide 5 or 15, the one we were just over.
Let me try this. Katie, it shows you there now.
I wonder why I'm not able. Oh, there.
Okay.
Okay, thank you. I'm sorry.
Oh, don't worry. It's computers glitch. That's what they do. All right, good. I like some of the lines I'm seeing. Remember, vertical is up and down, right? North to south. It's going to be up and down line. We're only worried about the vertical asymptotes right now, or vertical asymptote. But then what I want you to do is not only state what value that is, what value for that line, but also give me an explanation of why it ended up there. I mean, I know you visually found it, but did you look at the equation? If you haven't, look at the equation, because there's a big clue sitting right there. Think about what we learned with holes and what we learned with domains, and how can you explain the location of this asymptote? Good. I've got 9 students who have all chosen the correct answer, and that's 100% of you that are participating right now. So good job. And I see a lot of people just giving me the answer and not telling me why, though. So I really want you to challenge yourself to look at that equation and say, why is x equals -2 the correct answer? Why is that the important piece? Where do I see that in our equation? What's the big no-no with fractions? What can you not do? Good. I'm seeing the word undefined come up a lot, and I love it. Okay. Good. Really work on making your responses self-containing and complete. So rather than just saying you can't have a denominator that's undefined and that being your answer, you need to say why that would be undefined, or the denominator can't equal 0. That's a true statement, but it doesn't actually answer the question of why is the asymptote appear here. Well, it's because if x equals -2, then the denominator would equal 0, which is undefined, creating a vertical asymptote. Really step through the logic. Don't just jump around or hit the end. And we're no longer canceling. So holes required the canceling. For asymptotes, they don't. And in fact, they're like the half of a hole in terms of, that's kind of funny, the half of a hole, get it? Half of a hole, okay. So they are only concerned with like a domain restriction. It's not a 0 over 0 scenario like a hole was. It's just a over 0 scenario. So holes take both the top and the bottom, and they have to cancel. Asymptotes, for vertical asymptotes, it's just the bottom. Good. Excellent. I like it. I'm going to swoop you forward one. Actually, I'm swooping you forward 2 because this next one I know has an error in it. So we're going to go to slide 10. All right. So this just goes to show you can have more than one asymptote. Think about our day starter and how we had those graphs that had 3 segments. It's because they'd been chopped up by 2 vertical asymptotes in the ones that we had. So you can have more than one vertical asymptote. And in fact, you could have a lot of them. If you wanted to keep chopping up an equation, all you have to do is put on the bottom x minus or x plus whatever the number it is, the opposite of the number it is that you want to have an asymptote at. But what's going on here, and I've said this every time it's come up, and I'm going to say it, I'm going to keep doing it, because if you see a perfect square minus a perfect square, it's got to jump out and bite you on the nose. And you should be having your little hamster inside your head screaming, difference of squares, difference of squares. Right? So it's going to be x plus 2 in parentheses times x minus 2 in parentheses. That's the denominator here. If you factor that puppy out, because you've got the difference of squares, it's just got to jump out at you. Perfect square minus perfect square. The difference of squares is always going to be one of the parentheses will have a plus, the other one will have a minus, and then the letter in the number is just going to be the square root of your perfect squares. Square root of x squared is x. Square root of 4 is 2. So this one ends up being x plus 2 times x minus 2. If you solve those, ooh, Marielle, that one's looking great. I like using them. You can use the math type. If you guys are all catching on now, I love it. It makes me happy. That doesn't exist. You gotta be more specific than that for me. Don't just say things don't exist. Why doesn't it exist? Why at +2 and -2 does the function cease to exist? This will be the last one we get to, but I am going to want to do one more closeout type of thing here before we go. All right. I see some people in their explanation showing the math. Grab snapshots again. Make sure you're also talking through with the words. Oh, good. I like if-then statements. If-then statements really help you focus your logic so that you're not just coming up with an answer without an explanation to the answer. I grabbed a couple of snapshots, and I apologize if when I put these up, if you realize it's yours and it wasn't quite done yet, and that's why why I'm pointing out some things that are missing. But in the interest of time, I want to make sure that we have a chance to look at these. So let's see. Can you hop over to your oh my goodness, sorry. My housemate just got home and my dog is very excited. Hop over to Zoom so that you can see the screen. And I just want to point out a couple of things about these. Right. So this first one starts out great because it says, okay, it's the reason is a plus or minus is because the denominator is a perfect square. So it's referencing this plus or minus here. And then talking about the denominator being the difference of squares. So be careful with that. It's not a perfect square. It's the difference of squares. Right. So that's a great start to it. The next piece that would be important would be then, though, because this second one is missing this idea of the factoring. But if we put these two together, we would get the next step, which is important, which is saying if you have the x of +2 or -2, it would make the denominator equal 0. And then if it equals 0, then the function, we're just guessing this person was going to say, would be undefined, right? Obviously, that was what was coming. And then on this last one here, I love them showing the math. Showing the math is always super duper important, but you can't just leave it at that, right? You can't just say x can't equal ±2. Why not? I mean, why not? Why is there an asymptote there? So because it would turn the denominator into 0, which is undefined, therefore creating vertical asymptotes at the values of x equals +2 and x equals -2. That's what you would need to really complete your thoughts on those. So, but very nice job, you guys, all of you, and putting together good responses of thoughtful responses. So I'm going to swoop everybody to the very last slide here. And it's because it's going to give you an opportunity to kind of tell me how you're feeling about your understanding. For those of you that are still here, we've got a lot of people just dropped out like flies today. But tell me how your confidence level is. And if there's something else you want to tell me, please do tell me, because I would really like to know if there's a way that I can help you, or if you'd like a one-on-one session. After you guys leave, I'll take the anonymous off, so I'll know who's writing to me at that point in time. So you're more than welcome to say, I really need a one-on-one session with this Maz, because I'm confused about blah, blah, blah. And I will reach out to you and we will set that up, okay? I love the one-on-one sessions. They're my favorite part of my job. So the more you ask for them, the happier I get, okay? Awesome. Some of you are really feeling confident, and that makes me feel good. And that's okay if you're still struggling. This stuff takes practice. Right. And you'll find that in the CK12 stuff this week, there will be lots of practice embedded, obviously. So if you have questions, please make sure that you are willing to ask them, because it's the only way that I know that I can help you. Okay. All right. Good. As soon as you're done with this, unless you need to talk to me personally, you're welcome to peace out.
Peace out, Maz. Thank you.
Bye.
Thank you.
Thank you.
Thank you.
Thank you.
Good job, you guys.
You.
Thank you.
Bye. Martin, did you need to talk to me? Are you even there? Guess no. All right.